Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about AI agents. This episode is based on a tech blog titled How We Built AI Agents at Airtable, written by the Airtable engineering team. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Airtable is a cloud-based platform that blends the simplicity of a spreadsheet with the power of a relational database. It helps teams organize, manage, and collaborate on data so they can build custom applications and automate workflows. All of those could be done without writing code. Users can link tables across projects, create drag and drop interfaces, and set up automations for tasks like sending emails or triggering notifications. By 2025, the company has grown to an estimated 50 million monthly active users, with a strong adoption across both small business and enterprises. With the surge of generative AI tools like ChatGPT transforming productivity, Airtable needed to evolve its platform to meet those rising expectations. The team introduced features like AI Field, which allows users to generate text or content from their data. These early features were successful, but they came with clear limitations. They couldn't reason through more complex workflows or make decisions that require pulling in new information. Airtable also couldn't perform actions like fetching data from the internet, analyzing multiple tables, or building new interfaces on the fly. To push beyond these boundaries, the team wanted something more dynamic, something that allowed users to describe what they wanted in natural language and have the system break down the task, gather the right context, and figure out the steps to execute it. They also wanted a conversational interface where users could refine outputs, give feedback, and ask follow-up questions. That vision eventually led to the Airtable's AI agents, which is a system designed to understand intent, navigate the right resources, take actions, and learn continuously. Now that we've understood the business problem to solve, let's dive into the technical side to see how the team built their AI agent. At a high level, Airtable needed an agent that could remember information, perform predefined actions, and autonomously decide which actions were needed to satisfy the user's request. To support these features, they built the agent as an asynchronous, event-driven state machine. Everything the agent does revolves around processing events. When something new happens, like a user submitting a request or tooling finish the execution, the agent consumes that event, updates its internal state, and decides what to do next. This system relies on three core components. The first one is the context manager, and this acts as the agent's memory. It maintains everything the agent needs: the guideline context, which sets rules like tune and purpose; the session context, which covers the specific Airtable database, workspace, and interface the user is working in; and the event context, which is chronological list of everything that has happened in a session so far. Every decision the agent makes depends on this unified and constantly updated context. The second component is the tool dispatcher. You can think of this as the agent's toolbox. Each tool is a predefined action the agent is allowed to take, such as creating a table, updating a field, or generating text. The dispatcher exposes those tools to the agent and executes them safely when the agent requests them. This is critical because users might ask for complex tasks that require multiple steps. Instead of letting LLM directly manipulate the data, which is very risky, the agent must explicitly select tools, each of which is monitored, validated, and scoped. The final component is the decision engine, which serves as the brain of the system. This engine takes in all the context, evaluates the user's request, and decides what the next step should be. Depending on the use case, the decision engine might route control to an LLM for open-ended reasoning, rely on a fixed workflow for predictable tasks, or involve a human in the loop for sensitive actions. The engine keeps looping. It reads context, decides what to do next, triggers actions, observes the results, and repeats until the task is complete. Putting it all together, the agent's operation looks like a cycle. A request comes in, the context manager stores it, and the decision engine interprets it. If the agent needs more information, it will ask the user a clarifying question or fetch additional context from the session. If the agent identifies a clear path forward, it calls the tool through the dispatcher. Once the tool finishes, the result is added back into the context, and the decision engine evaluates again. This loop keeps running until the agent either completes the task or determines that it needs more user input. Within this architecture, the team observed one challenge, which is to ensure that all the context can fit into an LLM context window. These context windows have finite limits, and as a result, it's sometimes necessary to be selective about which context to forward to the LLM. The team leveraged a few different heuristics. One is trimming, which is a general strategy that removes content from the context before forwarding it to the LLM. Among the trimming approach, the team used several techniques: removing older messages, truncating two responses, especially the middle portion, and for large databases, removing irrelevant IDs, adjusting aliases, and removing unnecessary columns. These are all good practical approaches. Besides trimming, the team also found they could use LLMs to summarize content and minimize the removal of relevant information. For example, for large bases, asking a question such as analyze the sentiment across all feedbacks. This would require pulling in content from all records into the LLM. Instead, the team can divide the records among many different LLM calls. Have each LLM call perform the request on its set of data, and aggregate the results using another LLM with a summarization prompt, producing what is effectively a summary of summaries. These are all practical tips to ensure that the AI agents are developed well and are practically usable. Now we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how Airtable built AI agents, which is a system that lets users automate workflows using natural language. We looked at the business motivation behind making automation more accessible, and we broke down the technical architecture that makes these agents safe, reliable, and tightly integrated into their platform. It's a great example of how thoughtful engineering design can bring the power of AI to everyday business workflow without sacrificing control or transparency. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.